Um, Here's your notes for 6.2, using properties of exponents to simplify rational exponent expressions and using properties of radicals to simplify radical expressions. Since the last section, we learned how to mix these up, not mix them up, but transform exponent expressions into radical expressions. You can kind of use these interchangeably if you want. If you know these properties better and you have a radical, you can always transform it into this and then use these properties. Or you can transform these into radicals and then use properties of radicals. I'm going to go kind of fast through this first part because we did it in class. So I left my pin somewhere. There it is. Okay. Um, this is going to be the product of powers. So these are using the same um, So this is using the same properties that we used in the last chapter. We're just going to add this and this together since we have the same base. So 1/2 plus 1/4. 1/2 plus 1/4, that's going to be 2/4, so 3/4 equals 5 to the 3/4 power. Just keep in mind too is that you can leave it like that because it doesn't say what form it wants it in. This is exponent form. If they wanted it in radical form, you would put this as the 4th root of 5 to the 3rd, or you can even evaluate 5 to the 3rd to 125. Next one, this is the power of products, so you're basically going to quote-unquote distribute that in. 2 to the 1/2, that's just 1, so that's 8 times 5 to the 2/3, and that's it. Okay. If you wanted this in radical form, this is 8 times the 3rd root of 5 squared, or you can make the 5 squared to 25. This one, since you have a negative exponent, you can either do the negative exponent property, or you can multiply it in first with the power of products. I think in class you guys wanted me to do the negative exponent first, so we can do that. So 2 to the 4th times 3 to the 4th, positive 1/4 power, so that's a negative exponent property. And now we're going to go ahead and multiply it in. So you get 1 over 4 times 1/4 is 1, so it's 2 times 3, so 1 over 6, because that's multiplied there and there. And there you go. So we did that in class. So let's go ahead and move on to the stuff that some of the classes got to, some didn't. This is kind of new. I didn't show this in class, but then I thought about it, and I showed it on the whiteboard in class, so I'm not going to show it here. We know some properties of radicals already. Properties of square roots are radicals, so we can actually use the properties we've done in the past here. The properties we used in the past said that if we had the square root times another square root, you can multiply the insides of the square root. So you multiply 10 times 2 and get a 20. Same thing here. What you can do here is if you have square root of a fraction, you can put it as one big fraction. Reason why that helps is because 8 divided by 2 obviously is a 4, which is nicer to take a square root of. So basically, the parts we want to be focusing on is actually just getting the multiplying parts down. Okay. So connection to what we're doing right now is this. Just like with square roots, how we had the same square root, so we can put them together by either multiplying or dividing. Same thing here, since we have the same cube root, we can multiply these. So cube root means you're going to put it under one cube root, and then you can multiply the 4 times 16. 4 times 16 is 64. I'm going to go ahead and, if you guys are really good with, I'm trying to figure out if I want to show this or not. Here's one thing, always try to spot when you can turn these into perfect powers that you're trying to take the root of. Like this is a cube root. That's 4. 16 I'm noticing is a 4 times a 4. And I got 3 4s there. So this is cube root of 4 cubed equals 4. Another way you could have viewed this is 3/3 root of 4 times 16 is 64. And if you know that 64 is 4 cubed, then you can do cube root of 4 cubed and then get 4 still. Okay, so I think I showed this factor tree in the past when we did the square roots. So, but the connection here is this: if you have the same cube root, you can multiply the inside parts. Now, since exponents and radicals can be switched back and forth with each other, if I have the same power, I can actually multiply the bases together. Only if I have the same power. So 4 times 16 is 64, and then that's to the 1/3 power. Because I'm allowed, since they do have the same power, I can multiply the bases. And you'll notice too, hopefully, that this is the same thing as this. So we should be ending up with the same answers here. So 64 to the 1/3, 64, like we said before, is 4 cubed to the 1/3 power. Power of a power will tell us this is a 4. All right. Now this other piece down here, I showed this in class. I did it kind of a longer way. Sorry. Um, there's an actual better way to do this. Connecting this to what we said before, when you have the same roots, you can put it under one big root. So this is fourth root of 162 over 2. And now I can just divide this. So it's going to be fourth root of 81. 81, 9933. Okay, so let me show you what's going through my head when I'm doing these things. I'm doing like a little factor tree in my head. It's a 993333. This is 3 to the 4th power. So fourth root of 3 to the 4th power, and that is a 3. Now when I'm sitting here thinking, I'm actually doing this factor tree in my head. I'm trying to figure out, okay, what times what times what times what is 81. Now, if you're not that great with it in your head, you can actually do the factor tree out. I'm not going to take off points if you do that. Okay. So let's do this one too. Since we have the same power, I can take 162, divide it by 2, and put it to the same power. This will look like the power of quotients, actually, going kind of back to the properties. But this will be 81 to the 1/4. 81, once again, is 3 to the 4th power to the 1/4, which is 3. Okay, so we're going to be using that to do this next part. If you want to switch back and forth between these, I don't really mind. As long as you're getting the answers, that's fine with me, because these properties are actually interchangeable, because you can always transform one into the other and use whatever properties you want. Okay, starting with this one. 25 is actually a 5 squared. I'm noticing that right now. So I'm also noticing that they have the same index. So I know that I can put these both under here. 25 is a 5 squared times another 5. That's actually going to give me cube root of 5 to the 3rd power, which is just a 5. Okay. Now I know that some students will want to do this. They'll say, okay, but this I can write as, and then 25 times 5, and just do cube root of 125. 125 is 5 cubed, so that is a 5. I don't really care which way you do this, because they're both valid ways of doing it. I just always like looking for these exponents. If I can turn these numbers into perfect squares, perfect cubes, perfect 4th powers, a lot of times that makes my life a lot easier, rather than multiplying to get really big numbers and then trying to think about these big numbers to turn them back into this anyways. So you could also turn these into use properties of exponents here. It's up to you. I'll go ahead and show what that looks like too, just real quick. So if I were to take this and transform it, that'd be 25 to the 1/3 times 5 to the 1/3. Once again, I know 25 is a 5 squared to the 1/3 times 5 to the 1/3. It's 5 to the 2/3 times 5 to the 1/3. And now I know I'm supposed to add those. So that's 5 to the 3/3, which is a 5. Which gives us that 5. There you go. Okay, so a lot of different ways to approach this. That's where it gets kind of difficult here, is because there's so many different ways to think about it that sometimes you might get lost in your thoughts and end up doing, like for example, this is probably the longer method. This is probably the shortest one, but this isn't always going to be the shortest way to do it. So it's up to you to kind of figure out what works for you. Now, sometimes I'll tell you guys to put the radicals in simplest form. What that means is that you apply any properties that you can, remove any perfect nth power. So if it's the 3rd root and you can take out a cubed, you need to do that. And just like before, you shouldn't have any roots in the denominators. Oh, how did I get down there? It should be up here. Okay, so let's try this out. 3rd root of 54. So 54, which you should be thinking in your head is, or the way that I think about this is I try to find my perfect powers. So 54 is a 9 times a 6. That's probably the more one way to think about that. 9 is a 3, 3, 3, 2. So I got a perfect cube right there. So what I'm seeing here is I got a cube root of 3 to the third power times a 2. Just like we did with square roots, though, when you have a perfect cubed and it matches the index, you can pull this 3 out. So let's get a 3 cube root of 2, and you're done because there's no other perfect cubes within that 2. So basically, we looked at 54. We tried to find a perfect cube. Turned out to be a 3. Then we can take that out. Okay. So that is in simplest form. Now this one, we're going to come up with a different type of problem. Now first off, what I'm going to do is this 4, I'm going to turn it into something else. So I'm going to turn it into a 2 squared. So it's going to be a fifth root of 3 over fifth root of 2 squared. All right. Reason why I did that was because I know I'm going to be working with these exponent things, so I need to kind of keep that in mind. Now the thing is, I got a root on the bottom. I don't want a root on the bottom. To get rid of the root on the bottom, I need to do I need this. Fifth root of 2 to the 5th power. If I get that on the bottom, that's a good thing because I got a 5th root and a 5th power. Those will go away. I'll be ended up with a 2. Right now I don't have that. I got a 5th root of 2 squared. Here's where the fancy ones come in. So I'm going to do a 5th root because I need to get the same root. So what I'm going to be doing is I'm going to be multiplying the inside of this to the inside of this. So I got to get both 5th roots. So I got 2 squared, but I need 2 to the 5th. So when I get 2 to the 5th, I need 2 to the 3rd. So now if we look at this, if I multiply the inside, 2 squared times 2 to the 3rd is 2 to the 5th because you add the exponents together. So 5th root of 2 to the 3rd. Okay, so let's erase that. All right, so on the bottom, I will get 5th root of 2 to the 5th. On the top, I will get the, let's see here, 5th root of, hold on, 3 times 2 to the 3rd. Okay. Now, the bottom part just ends up being a 2. Top part, there's no perfect 5th powers in here. In order to get a perfect 5th power, you need like a 3 times a 3 times a 3 times a 3, 5 times, or 2 times 2 times 2 times 2, 5 times also. There's nothing. There's 3 2s, that's it. Can't really do much more than that, so I'm just going to multiply this all back together. 2 to the 3rd, 2, 4, 8 times 3 is 24. So 5th root of 24. And that's your answer. Okay, moving on. So example 4, just like I said before, we're trying to find perfect cubes because that's a cube power. Y to the 6, so I'll show you how you should probably be thinking about this too. So 125, you can do factor trees. So that's going to be a 5, actually 5 times 5 times 5 is 125. Y to the 6 is, you got 6 y's. Now, this will be the cube root of 5 cubed times y cubed and another y cubed. Reason being is because I'm trying to look for perfect cubes. So this will be 5y and y. 1 y comes out for each of these. So that's 5y squared. Now hopefully you kind of noticed there's a faster way to do this. The faster way to do this is like this. 125 is 5 cubed. Y squared is, y to the 6 is y squared to the 3rd power. There you go. This 3 will be gone. This 3 will also be gone. So you get 5y squared. There you go. Okay. All right. It's following in simplest form. So we can either leave this one in radical form or in rational exponent. If it's rational exponent, you're going to multiply this in. I do want to do 1/2 powers here because I got 1/2. So I'm going to do this 2 ways. That way you can kind of see both. So first way, I'm going to turn that into 3 squared. UV, and then this is v to the 5th squared to the 1/2 power. Okay. I'm going to multiply this into here, here, and here. So what this ends up being is 3 u to the 1/2 and v to the 5th, because 1/2 times 2 is 1. And it doesn't say anything about leaving it in radical, so that's, you could write it like this. I think another, I'm not sure where, I think I got this out of the book, but I think it wanted us to put it in radical form, but you can do it like this. If you think about this, this is 3v to the 5th, and then this is going to be a square root of u. So let's see if we can get that just by a different way. So the way we can do this is convert it first to the square root of 9uv10. You know the square root of 9 is a 3, so that one's taken care of. Or one way you can rewrite this is 3 squared uv to the 5th squared. Because remember, we're trying to get squares since this is an index of 2. I could bring out a 3. The u can't come out because there's no squares. That's v to the 5th can come out because the squares will cancel, and you end up with square root of u. So same answer. Okay, so let's try this one. Let's get 5th powers going here. So 5th powers. So 5 can't really turn 9 to the 5th power. 8 to the 5th power, nice and neat. B, 9 is, so we're going to be using different properties here to try to help us out here. So b to the 5th times b to the 4th is b to the 9th power. C to the 13th, same thing. That's not a multiple of 5, so I can't really, do the power of a power thing I was doing before. But c to the 13th, think about that, that's c to the 10th times c to the 3rd. And c to the 10th is c to the 5th squared. So there you go. That's what's within your 5th power. So I'm going to underline the ones that are coming out. This is coming out, that's coming out, and this is coming out, and I wrote that backwards. Sorry about that, because I'm looking for 5th powers. So I want the 5th power out here, 2nd power in there. 2 times 5 is still 10. Okay, so what's coming out is an a b, and a c squared. What's going back in is the 5. So that's gone, that's gone, that's gone. The 5, the b to the 4th, and the c to the 3rd. All right. Now, the other way you can do that is to prime factor this. So that'd be 5, 1, 2, 3, 4, 5, b, do 9 b's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 13 c's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then find the 5s. There's 5 of those, 2 pairs of 5s of those. Oh wait, that wasn't 5. Sorry. 5 of these, 5 of these, there's 4 B's, and then 2 pairs of 5s of C's. So you can bring out an A, a B, and then a C squared. What goes back into the 5 of B to the 4th and C cubed. So either way you want to do this is fine, but I mean you can kind of see how this can get really lengthy. If this is like C to the 27th power, you probably won't want to do all this. Okay, you want to try to break it into so it's a multiple of this index. So like this one was a 10 and a 3. Technically, you could do C5, C5 instead of doing the C squared 5 if you wanted to also. So different ways to approach that. And then we'll make this one the last one. Okay, so cube root of x, cube root of y to the 7th. Now I'm going to simplify the bottom part before I start trying to rationalize it. Y to the 7th. So let me do this in red. This can be the cube root of y to the 6th times y to the 1st, because remember I want a multiple of 3. Now I can either think of this as there's 2 groups of y to the 3rds in y to the 6th, or I can rewrite y to the 6th as y to the 2nd power cubed, because now I got my cubes to match up. So I know I got a y that can come out. So I got a cube root of x over a y squared comes out. and then I still got a cube root of y here. All right. And now I need to rationalize that cube root of y. So for that cube root of y, what we're going to do here is we got one y down there. We need to multiply by a fancy 1. So let me put this off to the side. So fancy 1, what I need is cube root of y cubed. Right now I got cube root of y. So I'm going to multiply by a cube root of y squared, because that will give me my 3y's, cube root of y squared. Okay. So what I'll get is y squared. Those cube roots of y, cube root of y squared is just going to end up being another y on the bottom. And then we're going to get a cube root of xy squared up here. So you'll get cube root of xy squared over y cubed. All right. And there you go. That's how you're going to use these things to kind of help you simplify these. A little difficult. I'm going to give you guys tomorrow to try it out with the sub. Friday, I'll check back in with you and see how you did. If not very well, then we'll work on it again. Okay, so sub work tomorrow is going to be actually do the entire worksheet, 1 through 23, all. And you're going to be doing that in class tomorrow with the sub, so that you guys can help each other out too. Okay, all right, bye-bye, bye-bye.